Welcome back, Math 098. Thanks for watching. We got chapter 8, section 4, and we're just going to do a little bit more with solving and graphing and writing our answers in interval notation, and I'm going to show you what graphs are that we are. So we're doing a little bit more than just x-intercepts. We can still use the quadratic formula. But now what's different is when you see a greater than symbol, think about how greater than means positive. So this is basically saying, this entire statement is basically saying positive y values. Now it still deals with x-intercepts because what we're looking for is where we're above the x-axis. So you still need to find your x-intercepts. Whereas when you look at this one, it's less than or equal to 0, so it can be on the x-axis, but less than means negative y values. So the or equal to just sort of says or, so I should write below first, below or on the x-axis. So slightly different, and we'll get to that when we get to it. So what it boils down to is if we did this problem as if it said equal 0. Well, if it said equal 0, then we would just say x is equal to 4 or x is equal to negative 3. Now, this is not my final answer because these are where the equation equals 0. And we don't want where they equal 0. We want where it's greater than 0. Now, I have a couple ways of doing this, and it's really up to you which method you want to use. The first method that the book actually uses is they write a number line, and they put this in order, so they write negative 3 before 4. And what they do is they choose a number that is to the left of negative 3. So a choosing option would be something like negative 4. Well, if you put negative 4 in for this x and this x, negative 4 minus 4 gives me a negative 8. And negative 4 plus 3 gives me a negative 1. And what happens if I do a negative times a negative? I get a positive. So this section of the graph works because it's true that a negative times a negative is positive. It's greater than 0. So then choose a number between negative 3 and 4. The easiest option in this case would be 0. Well, if I plug in 0 minus 4, I still get a negative, but 0 plus 3 is now a positive. And what happens when I do a negative times a positive? I get a negative, so this does not work. So we don't want that answer. And then we're going to choose a number that's to the right of 4, say 5. Keep the numbers pretty simple. 5 is bigger than 4, just like negative 4 is smaller than negative 3. I'm trying to color code this so you see it pretty well. So 5 minus 4 is a positive. I'll just cross that off. 5 minus 4 is positive 1. And 5 plus 3 is positive 8. Well, positive 1 times positive 8 is a positive number. I don't really care what number it is. I just care that it's greater than 0. So this works. So this is what they're talking about for the graph. Notice that I had open circles because we didn't want where they equal. And so in interval notation, we would write it this way, from negative infinity to negative 3, union, we've done this before, 4 to infinity. Now, if anybody's curious, the other way of doing this is through the use of a graphing calculator. Now, I can do this in my head, and I think you guys can as well, because if you were to look at the quadratic, x times x is x squared, the graph of this is an upwards u, because it's a positive leading coefficient. And so if you were to examine in the graph, that's a pretty poorly drawn, but I don't really care. Right here is negative 3. And right here is positive 4. Where is it above the x-axis? to the left of negative 3, just stated right here, and to the right of 4, which is stated right here. And you can verify that with a graphing calculator. Just go to y equals and clear this out so there's no confusion. What do we have? X minus 3. Oh, it's minus 4, sorry. X plus 3. And if I hit zoom 6, because I've probably zoomed in, you can see exactly what I told you the graph would look like. And it's above the x-axis to the left of negative 3 and above the x-axis to the right of 4. So let me change colors and just kind of walk you through the next one because it's not factored. Well, if you factor out an x there, x minus 8, still less than or equal to 0, but now the zeros we care about are x equals 0 and x equals 8. This time when we're looking at the graph, we want to include 0 and 8 on the problem. So we put a closed circle there, and that's super important because it's or equal to. But this time when we consider less than, and you pick numbers that, to the left of 0, like negative 1, between 0 and 8, I would just do 1. And if you pick a number to the right of 8, like 9, what you'll see is the only way to get a negative is if we have numbers in between the two of them. Now, I'll let you investigate this on your own, but I'm going to try and keep these videos somewhat short. Because if you plug in 1 for x, you get a positive. 1 minus 8 is a negative, and a positive times a negative is a negative, what we want. So the only one that works is between. And my thought process, sort of like how I did this graph, is the same for x squared minus 8. That graph looks like that with a positive leading coefficient. It's only below the x-axis between 0 and 8. So how do we write our answer in interval notation? This time with a bracket because we want to be on the x-axis as well, or equal to, so brackets, 0 to 8. This is the answer I'm looking for. So be ready to do all of these types of things on the problem. So there's just, I have 4 examples on this page that kind of walk you through everything else. But if you notice, this is actually the same problem as before, except it's, as you work through it, the only difference is we want to be positive. Greater than 0 is positive, so above the x-axis or on the x-axis. I don't like how I'm phrasing this. Positive numbers, that would be above or on the x-axis. So you can examine that you have x equals 0 and x equals 8. And so when you look at that and you kind of work through all the options, the ones that work will be to the left of 0. Notice my bracket, notice my closed circle, I should say, and it will become a bracket. So our answer will be from negative infinity to 0 with a bracket, union 8 to infinity. Now this next problem is getting more complicated. But when you find all of your zeros, because it's already factored for you, we have negative 3, positive 2, and negative 1. So if you're doing it the way the book wants you to do this, we would have negative 3, negative 1, and 2. Make sure that you go in order, because when you pick numbers, I'll switch back the way I was doing it at the beginning. With negative 4 is a number smaller than negative 3. Negative 2 is between. 0 is between negative 1 and 2. And then I'll just do 3. And if you start all the way to the left, well, all 3 of these are going to be negatives. Because negative 4 plus 3 is a negative. Negative 4 minus 2 is negative 6. I just care that it's negative. And negative 4 plus 1 is negative 3. It's a negative. A negative times a negative times a negative is going to give me a negative. So this works. Because remember, being less than 0 means that we want negative numbers. We're going to fill in the circle because of the or equal to. And here's the thing, is after some practice, you'll notice that they alternate. Usually. Sometimes they do not alternate, so you have to be careful here. At this juncture, I'm going to suggest that you try every option. And the only thing that's different on this one, when you plug in -2 plus 3, this will change this to a positive. -2 minus 2 is still negative, and -2 plus 1 is still negative. Well, this time it doesn't work because a positive times a negative is positive. 0 will work. So numbers between -1 and 2, those do work. Because you get a positive times a negative, 0 minus 2 is negative, and 0 plus 1 is a positive now. And a positive times a positive is negative. That's what we want. We want negative numbers. I guess I should have wrote that to begin with. And then 3 will not work because they're all positive. And a positive times a positive times a positive is positive. So what's my answer? Remember, infinity always has a parenthesis, but then -3 will have a bracket. And then -1 will have a bracket until we get to 2. Notice I'm writing down the values that I want, that my endpoints are, not the numbers I put in for x. This answer should make sense, because if you were to multiply x times x times x, you would see it's an x cubed. And you should remember from Algebra 2, a cubic function with a positive leading coefficient at a +1, if you multiplied all that out, goes this direction. And if we examine where it's below the x-axis, it's below the x-axis from -infinity until the first 0, and then from the second 0 to the third 0. And I'm counting in order. So when you're using a graphing calculator, we care about this region that I'm trying to bold in. I also like using a white marker sometimes, so that's what I was doing there. So you can use a graphing calculator to check that you have the correct answer. At the end of the day, it is up to you. And also, as I mentioned at the beginning of these notes, you might need to use a graphing calculator. Because this, when I set this greater than 0, I hope you realize that this is not factorable. There are no factors of 4 that add to be 2, so that's using the quadratic formula. X equals -b plus or minus a radical, b squared minus 4ac all over 2a. I don't need to write a down because a is 1. But if you notice inside the radical, what do we get? We get a -12. What does that mean? Well, that means it never crosses the x-axis. Never crosses the x-axis. So this might be where you want to use a graphing calculator. But I think you guys are smart to recognize that it's a parabola that's going upwards that never crosses the x-axis. The only possible option here is that the parabola is always above the x-axis, which is why I like for students to write out that this means that we want to be above the x-axis. Well, it's above the x-axis everywhere. So how do we write our answer in interval notation? Well, everywhere means from -infinity to +infinity. There you go. I'm close to my time limit, so why don't you try this next one on your own, and I'll have the answer in a second video. So I'll explain this in a second video, and then I have a few rational functions to talk about, but you should be able to start your assignment here.